Okay, let's see if we can finish out these problems that we were working on. I'm going to redo part C, and that we had the H naught from the problem is mu equals 75, and the alternate hypothesis is mu is greater than 75, and that's parts 1 and 2 of our 7-step process. Part 3 would be to identify that we're going to use the Z statistic, and that's going to be x bar minus mu naught over S over square root of n. And then part 4 is we want to draw, in this case we're doing alpha equals 0.10, so we'll do alpha equals 0.10 and create my drawing there. I know that's my 0. And from my alternate hypothesis, I know that mu is greater than 75, so I'm going to have a right-tailed rejection region, and it has a size of alpha equals 0.1, which makes my area to the left of it a 0.4, so you just take it away from 0.5. And then for that, a 0.4, if I go to my table, I can see 0.3997 is the closest, and that comes to 1.28, so 1.28 there. So that'll be a 1.28. That 1.28 gives me an area of 0.1 for my alpha, and so that's my rejection region, that whole area there. So I'm just going to write rejection region, and that is if my Z is greater than 1.28. So then I need to go to step 5, which is my assumptions. And since I'm using a Z statistic, I want to have had a random sample. And I don't think we know anything about it, so we'll just put a question mark. And my n needs to be greater than or equal 30. And for that, I also don't know my n, so I don't know that for sure. And then S estimates sigma, so that's my point estimator for sigma. Okay, step 6 then is to calculate. And remember, that's where you perform the actual experiment that they're giving us some of the data for. And the data they're giving us is that Z is 1.63. So they've told us Z equals 1.63. So they calculated their Z statistic using the X bar from their sample and the S from their sample and the N from their sample, and they came out with a positive 1.63. So when I make a picture that looks like this, and zeros here in the middle, my actual data from my X bar gave me the 1.63, and so what I'm saying is that this is the area to the right because we're looking for it to be greater than the 75. So this area to the right, and I want to know what that area is, so I'm just going to look up the 1.63 on my chart. So 1.60123, so it's going to be 0.4484. So that means this piece, the big piece, right up to the 1.63, 4484. And if I want this piece, I'm going to have to do 0.5 minus the 0.4484. And when I subtract those two, I'm getting the 0.0516. And remember, that's what they gave us at the beginning for the two-tailed, and then when we divided it, we got the 0.0516. So there we have the area for the actual data, and remember, this is our p-value. It always goes with the actual data or the sample that you took. Our rejection region is 1.28. So if I merge those two pictures, I'm going to draw it off to the side. I know you were starting to get it, and so I just want to reinforce for you that you've got the right idea. Here's my 0, and I know the 1.28 is going to be first, and then the 1.63. And so what that's telling me is that I'll do my rejection region in red. So if my test data falls into the red region, then I will reject H0, and here is the test data itself, and I'm making it blue on top of the red. So this is our test, and this is our rejection region. And you can see that our test data falls completely within our rejection region. So we have sufficient evidence to reject H0 at a 0.10 level of significance. And since we don't really have a scenario, it's just numbers, that's about the best we can do for our conclusion. So I'll mark that as part 7. So again, we are comparing our rejection region to the region that we get the probability of our actual sample data of where it falls in the distribution. And since this distribution was smaller than our rejection region, or in this case our p-value is greater than our alpha, then we're going to reject H0.